Let's continue to develop our skills in designing hypotheses by looking at example B. Example B says, an engineer hypothesizes that the mean number of defects can be decreased in a manufacturing process of USB drives by using robots instead of humans for certain tasks. The mean number of defective drives per 1,000 is 18. So, the mean number of defects is 18 per 1,000. And this time, the question is, can this mean number of defects be decreased? So in other words, after employing this process of using robots to do these tasks, will the mean be less than 18? So the question is, will the population mean be less than 18? Again, let's keep in mind that we are going to use a sample to draw a conclusion about a population. And whenever we do that, we introduce the possibility of sampling error. So as we stated before, if the sample size is sufficient, we expect the sampling distribution to sufficiently approximate the distribution of the population. So again, we will find ourselves a random sample, and from that sample, calculate a sample mean. And if that sample mean were to land, say, up here to the right, greater than 18, then it would in no way support this conjecture that the population mean is less than 18. And if our sample mean were a little less than 18, then we wouldn't necessarily conclude that the population mean is less than 18. Again, in order for this sample to lead us to draw the conclusion that the population mean is less than 18, that sample mean would have to be significantly less than 18. And again, significantly less means that we would land down here where it is very unlikely that we would land if the population mean is in fact 18. There isn't much area under this curve from this point out. But again, this would be our unlikely area down here. Now again, remember that this unlikely area is what we're going to call the rejection region. And recall that the null hypothesis is the hypothesis that we would reject if our sample mean lands in the rejection region. And what we would reject is that the population mean is equal to 18. The alternative hypothesis is what we would conclude if we reject the null hypothesis. And if we land way down here and reject the null hypothesis, then we would be willing to conclude that the population mean is less than 18. Again, let's note that we have a one-tailed test. We don't care about what's up here to the right. If the question is the population mean actually less than 18? We only care what's down here to the left, and so our rejection region will be concentrated down here in the left tail.